Hi, I'm Lily, and I'll be presenting Lab 1 Charged Tapes. The goal of this lab was simple but powerful: to use clear tape to study the charge interactions and estimate the actual number of electrons lost. With tape, a ruler, and a flat surface, we created charged U-tapes. From our measurements, we found each tape carried about 3.7 times 10 to the negative 9th coulombs. To put that in perspective, that's equivalent to losing around 2.3 times 10 to the 10th electrons. A large number for such a small piece of tape. This lab connects to three core physics concepts: Newton's second law, which links forces to motion; Coulomb's law, which describes the electric force between charges; and gravitational force, which gave us a way to compare electric effects to something familiar: the weight of the tape. By balancing these forces, we could make a quantitative link between theory and experiment. We saw the two U-tapes repel, meaning they had the same sign of charge. They were attracted to a hand because neutral objects polarize in an electric field. And when brought near a pen that had been rubbed on clothing, the tapes were strongly attracted. Since the pen was negatively charged, this confirmed the tapes were positively charged. These simple interactions helped us piece together the charge sign and behavior before moving into calculations. We prepared U-tapes by layering and peeling strips, suspended one so it could spring freely, and brought another close. We measured the equilibrium separation distance of 0.008 meters. To model the system, we assumed the tape's charge was concentrated at its center and ignored air resistance. These assumptions let us use Coulomb's law cleanly to compare with the gravitational force. At equilibrium, the upward force equaled the downward gravitational force. Solving that gave the tape's charge, 3.7 times 10 to the negative 9th coulombs. We found that each tape lost about 2.3 times 10 to the 10th electrons. It's striking how such a massive number of electrons results in a very small but still measurable charge. Here's the breakdown of a computational model I created using the scenario we observed during lab along with the specific measurement. Of course, our model did have some assumptions, including equal charge distribution, negligible air resistance, and accurate measurements. In reality, charge could have been unevenly spread, or some lost through contact with hands or the environment. We also considered two thought questions. 1. What if electrons and protons had opposite charges? In that case, the direction of fields would reverse, but interactions would look the same. The tapes would still repel, and the pen would still attract them. Also, what happens to charge over time? Contact with hands or air slowly neutralizes the tape, weakening the electrostatic effects. This shows how sensitive these systems are to the environment. So, in conclusion, this lab demonstrated how even with something as ordinary as tape, we can test Coulomb's law, quantify electric forces, and explore what happens if we push on the assumptions of physics. Thank you.